Picacho Peak, about 50 miles north of Tucson. It's the only place in Arizona where a Civil War battle was fought between the Union and the Southern armies. Mr. B didn't want to get out of the vehicle there. It's still a little cool here this morning, about 8 o'clock. Oh, I see. He's getting out. Getting out, testing the weather. Well, here at Picacho Trading Post here. The view of Picacho Peak, about 4 or 5 miles down the road, shows you a little bit more of what it really looks like.
That's the sign. Okay, there's Mr. Elliott down there by the sign.
Well, here we are at the Titan Museum. The only ICBM museum of its kind in the world. Say hello to the natives, Mr. B.
Look at that antenna up there. The sun's right in the way. You're going to have to move to take a picture of it.
Area. Again, at the top of the steps, there's another telephone. The commander would have to call again, but he's being viewed by camera right now. He would give the code for the day. Before he left Davis Mountain, he was always given the duress word. If there was any reason for an unauthorized person in here, he would use that duress word. The door behind him had been closed and locked. This one remained locked. And then, of course, they would call the security patrol that patrolled in that little Jeep. Constantly, the Army was trying to train people to break this security, and no one ever got beyond this door. But that's the only way they found out how good their watchdog was. The little red coffee can on the side of the screen up there wasn't for cigarette butts. That's where they burn the code for the day and seal the camera. You'll hear a loud bell when that elevator door closes, so don't worry. Here would push the next button, and these pins would be pulled back. Then the door would be opened manually by the crew. Now the edges are so finely milled that when the door is closed, it forms a neoprene seal. Absolutely nothing can get beyond this door. There's an interlock system. No two doors can be opened at the same time. So when this door would be closed, this little latch would then pull these pins back and release the hydraulic pressure on the next door. Hardened area. This is to protect the crew down here. That area out there would not survive an earthquake or a near hit. It would all fall down here. But from here on, it is a hardened area. Spring mounted. These lights are spring mounted. This whole electrical panel is spring mounted. And of course, the reason for earth movement. Also, the pipes have flex. That's 3 tons. How about that?
Did they ever have to plane them off?
Bolts on the floor do not touch. It's very, very separate. It's built like an egg. Okay? It's called rattle. Welcome to take pictures down here. If you want to pose friend or foe in the commander's chair, do so. I'll keep on talking because our time is up. Combat crew commander would sit. Of course, one of his jobs was to monitor the pressure in the fuel tank, all 4 fuel tanks on the missile. Going around the room, oh, here's another little bug. I think you better come over and find this one. Usually they're right in your face, you know. Here are the controls for the, and you're not going to jump on this and start this moving because I can see this. The pressure intake of the silver pipe over there, that will automatically seal if there's so much as 2 pounds of overpressure per square inch, or stolen lock, and do only the combination to that lock, and half of the combination to the safe. The exchange of command in the morning would be that the officers leaving would remove their lock. The oncoming crew then would take an inventory of the safe to make sure that nothing had been tampered with, and if everything was all right, they put their locks on, and they would be ready for the day. In the red safe are the 2 launch keys to going to war documents in the seal packet and decoding books. Communication equipment. But when this site was deactivated in November of '82, the Air Force took it all out because they could use it. And now that the sites are all deactivated, we're getting it back piecemeal. And it so happens that 2 of our tour guides happen to be retired Air Force, retired electrical engineers. And they're having fun putting these things back where they belong as we get them. Zulu Greenwich time, international time. That's the time that all Army installations would use. 7 hours difference between that time and our time up here in Green Valley. This is launch time. This is lunch time. The locator board. Steve told you that anyone working on the premises had to be in contact with a deputy, and this is where he would keep track of them. He'd write them down in a grease pencil. If they moved, they'd have to let him know where they were. The antenna board. This is where those pop-ups would be operated. As Steve told you, the deputy would set his frequency for operation, and the pop-up would rise to that frequency. The entrapment area. This is live. If anyone was there, we could see it. The power board. We bought commercial power from Trico Electric. Well, you know what happens any place in the country, and especially here during our monsoon seasons, it goes out. So to back that up, there is a diesel generator on the next level that would come online, give us 350 kilowatts of power, everything that Trico gave. Well, if that failed, there were storage batteries on the next level that would give emergency lighting only, plus the 28 volts of direct current. Highly trained technicians. The VMAC was in charge of everything regarding the missile. This shows the Tipsy system top side. There was a visual as well as an audio signal. And you saw in the video how every 12 hours at least, the VMAC would have to check to make sure that things were operating the way they were supposed to. If there was a malfunction somewhere along here, there is textbooks. If it was a more serious problem, we would pull about 8 alerts every month and would go through the actual launch of a missile using this panel down here. The next person was the MFT, and he was in charge of all the power throughout the complex. These are circuit breakers. 103 is the one that is very crucial. It would come on during launch. This is the breaker that activates the squibs that would release the 4 bolts on that thrust mount down at the bottom of the launch duct. But in 1978, MIT and AC Spark Plug Division of General Motors came up with a very efficient all-inertial guidance system. So when that was installed, all we needed then was this guidance control indicator and what SAC headquarters need, perforated target listing the 3 targets, and then it would be played back to make sure that the information was stored correctly in the missile. Looks a little bit out of date, doesn't it? But it did the trick. And of course, if the information was correct, then we'd get the green light saying that we could launch. As soon as this would start, ooh, it sounds terrible. The 2 officers would get out their red books and copy the message. They had to agree.
Romeo, Oscar, November, Charlie, Tango, Tango, Lima, Alpha. Authentication 22040, Delta, Lima. I have a valid message. Stand by to authenticate. I agree with authentication officer.
They're going to the red safe now. Breaking open the war documents.
After launch
Launch codes entered up here, 6 digits.
launch order confirmed. Hold.
The butterfly valve was controlled by this code that would be entered. 6 digits, and on each wheel, 16 more characters. Do you have any idea how many different combinations there could be? No mathematician. See, I thought that myself. Would you believe 16,777,216 different combinations? Very complicated. Okay, now, the launch message contained all the crucial information that the crew had to know. First of all, the only one that could authorize the use of a nuclear weapon is the president. He would go to Chief of Staff and SAC headquarters and could get to a missile base in about 5 minutes. So the information that the crew had to know would be the code to operate the butterfly valve, had to know the time of launch, and of course the target selection. Target 1, target 2, or target 3. Put it back on 2 because that is primary target, and target 2 is programmed for an air burst. If we wanted a ground burst, we'd get a key out here and insert the key and turn it to the ground burst. Now, we're going to launch the missile. The commander's key would go here, the deputy is over here. These keys have to be turned within 2 seconds of each other and held for 5 seconds. They're also spring-mounted, so you see it takes 2 people to do it. So, I'm going to turn the key, and you can watch the sequence either here or up here. We have a green light, which means that we've entered the butterfly valve code correctly. All of these things have come on already. Now, what is happening? The acid is being poured into the batteries aboard the missile automatically. And when that is done, then that silo door will start to open. When the silo door starts to open, it's going to break the tipsy. So we will get that signal down here that the door is being opened. And if I had timed this right, I would have ended up with 15 seconds of conversation, and we would have the signal right now. How about that?
I thought of that.
Did you hear? I don't do it too often, but it's fun when it ends up that way. Okay, now you see how far we've progressed in this sequence. When that means that everything is set to go. The next light will be liftoff. 59 seconds for the launch sequence. Do you have any questions about the fire? The door would be closed, that huge door would be closed, and the crew would remain here for further orders. We're talking about 1850 technology. During that period of the missile technology. Any questions?
How long did it take to build this?
That's a good question. 18 months, huge, big hole. And of course, to bring in all of this heavy equipment, they couldn't begin to bring it down with the elevator. And how they built and covered it up. And there were a lot of subcontractors. And the ironic thing is when...
Pick up the phone, Mr. B. Call the president.
They had an accident in Arkansas.
He has gone mad.
It does protect. The tunnel is...
Mr. Corrigan, you can see he has gone mad.
All the electrical cables, all the things.
Let's see, Mr. Corrigan, you live in Aiea, Hawaii, right? I'm going to totally destruct you. This is from world headquarters. Well, this time I wanted to be sure to bring a video camera. Last time I just brought my regular camera. Now this is the walkway to the actual missile.
200 feet from the command center down to the silo. And it is completely suspended. Metal frame, completely suspended. Springs on each side, and support on your left, cable to go down to the missile. On your right, the one that you'll touch. This is the cable for the radios, right above here, and all the pipes above, which are the electrical wire.
What do you think, Mr. B?
Well, you come into the launch duct area, and this is what we were looking down from the surface. This is the barrel of the cannon. It's not the silo. That's the silo up there. You notice the floor doesn't touch that silo wall, so that even if that 8-foot thick wall were doing some vibrating, it doesn't carry through to the floor. Go out there and work, such as the fuel handlers did. They went out there with a portable vapor detector. We'll see them a little bit better in a minute. And they're checking the fitting for a leak. They have a portable vapor sensor for vibration and sound. So they dump all that water, 9,000 gallons of water in 1 minute. And you have a sound attenuating material. We'll see that better. That line. Everybody see?
Now walking around the actual missile silo here.
So these are the water chillers. These would be operating, two of them would be operating at all times, and then there'd be a third kept as a spare reserve. The level right below us, 6-cylinder, 510 horsepower diesel electric generator.
These are the hydraulic tubes that operate the platforms up and down the work platform.
Oh, okay.
That's only a bed line. That would not ordinarily be hooked up. But those black lines you see that are plugged into the missile, those are the lines coming from the command center. Those are all the instruments.
These doors would drop down, or these platforms would drop down from the wall to allow the workers to go out and work on the missile.
As that missile rises out of the silo, those would actually pull, release cords on it, pull it loose. The work platforms have been removed from in front of the windows. The windows were installed for the museum in the late 70s. It was upgraded and they did away with it.
What do you think, Mr. B?
I'll think that's fair.
Think we could hit Corrigan's condo with this?
I think about 6 inches.
Yeah.
Steel. Everything in the launch duct would be destroyed if the missile were fired. We could see all the hoses, wiring, and things with people.
I'm looking at the
Military? Yes, especially trained Air Force
warhead and the
crews did not wear
heat shield
on the backpacks. They have
protecting it. Looking up through the plexiglass that is on the
top
top.
here is a 1-hour pack, and this is a 2-hour pack. They're not air conditioned.
102 feet in length and more than 10 feet in diameter. And this is 2-stage. First stage, approximately 67 feet long.
1962 times 54 missiles.
actual silo, and
The end of the Titan II.
everything is on springs down here.
What did he actually? Oh, yeah. Either had to pump it off or pump it on. And maintain the temperature of the water, children apparatus, and the necessary people to monitor it. This is kind of...
So it doesn't cost as much to maintain that solid food?
No, it's not. They're much more efficient. And that is temperature sensitive, even although they're in a silo doesn't have to be kept such a critical temperature. We are running kind of late.
Out of the actual missile silo, crunched down a little bit so he wasn't hit his head. Entry portal where the missile crew would enter and go down into the actual command center.
There's Mr. Elliott. He's a civilian worker with the 390th there.
Also known as Dr. Strangelove. Antenna that was used to communicate with Davis Monson Air Force Base and also SAC headquarters. For Mr. Corrigan, that SAC stands for Strategic Air Command. I was told that by an old retired Air Force guy with a beard. The redhead up in Las Vegas getting into SAC, I was told. Again, I was told this by an old retired Air Force general with a beard. This is a cooling tower pit, as you can see from the sign, where they would just run the water in case of launch. There would be over 9,000 gallons of water down at the base of the missile. The hydrazine fueling pit, the fuels that they used upon contact would explode and cause combustion. And this is the hydrazine side. A tank truck would pull up in here and pump the fuel down into the missile silo. Doppler radar, the tipsy is the metal one, not the gentleman standing next to the sign. And it was a Doppler effect radar that would detect any movement above ground here, and then they would call in the security. It was to warn the combat crew of any possible penetration of the silo. I don't know what happened to the other tipsy that walked away.
Field day.
Hey, make good field day, trailer, Mr. Corrigan. I mean, it's not for Miller time, Mr. Corrigan. This is used in case there was a spill of the hydrazine or the liquid oxygen that it was very flammable, and so they would want to put the fire out. However, you could probably use it to pump your Miller, because the first stage rocket engine here that fired the missile. This is the overall view of the engine. Mr. Belcher, would you point out the butterfly valve that allowed the two oxygen or the two propellants to go together? The butterfly valve lock that allowed the two propellants to come together if the launch code received by the crewman was correct. And this butterfly valve would open, allowing the hydrazine and the oxidizer to flow together, causing immediate combustion and firing the rocket engine. Actual warhead that was atop of the Titan II missile. The heat shield is that brown plastic-looking stuff, and would keep it from burning up as it re-entered the atmosphere. The second stage, which would be tumbling and following the warhead, being made of metal, would disintegrate upon re-entry. That the oxidizer was held in until it got a temperature of 60 degrees before it was pumped down into the missile. Looking down from the top of the silo door down into the actual tip of the missile or the warhead. Half of the top of the silo door is plexiglass. So in order for the Soviet spy satellites to be able to look down and verify that the missile was inactive, half of the door has to be plexiglass.
That's now, when it's active.
That's correct. As Mr. Belcher pointed out, when the system was active, the door was solid concrete and slid over the top of the silo. The antenna made by Collins Radio could go anywhere from 7 feet high to how much, Mr. B?
Just the top section, if that stuck up from the base alone, it would be 7 feet. If the whole thing goes all the way up to the top, which is farther than they got now, it could go to 117 feet, but it all depends on what frequency.
On what frequency they wanted to use.
Depends on if the band's open or not.
If the band's open. Made by Collins Radio. Concrete pads, bumper pads, prevent the door from ever moving open again and sliding across. It prevents the door from opening. Again, this was under the treaty with the Russians to verify that the door could not be opened. An interesting tour here.